Okay, so here's a follow-up video to the logarithms and exponentials review that had some solving in there. Maybe not quite the level that we do in this class, so we'll do a couple more that are a little bit more challenging, is the best way to put it. So included here, we've got exponentials with common base, exponentials without a common base, and then just kind of the all-encompassing logarithm. So let's get into it. Every single one of these is going to be solved, so we're just going to solve them. Okay, so we take a look at the very first one. Always pay attention to where your variable is. If the variable is in the exponent, then you need to be able to get to the exponents. Whatever you do, if you have an exponential, try to get the bases to match if you can. If you can't, then yes, of course, use logarithms as a tool here. But if we take a look at question number one, my x's are both in the exponents. That's good. Can I match the bases? Yes, of course I can. So with an 8 and a 2, I can use a base of 2. So if I replace the left-hand side with a 2 cubed, and just carry down the exponent that's already there. This one doesn't need to change. It already has the base of 2, which is really nice. In this case, when you have those exponents kind of duking it out next to each other, I guess, you're going to distribute. So highly recommend parentheses when you replace the 8. So this is going to be 2 to the, make sure you distribute, 3x plus 3 is equal to 2 to the 2x minus 1. Now remember that an equation is just a true statement. Like whatever's on the left-hand side is equivalent to whatever's on the right-hand side. So if we have the bases matching, you've already satisfied those being equivalent. So the base of 2 and the base of 2. Now you just need to satisfy that the exponents are equivalent. So I'm just going to kind of disregard those 2's at this point because I've already checked those off the list. And we're just going to take a look at the equation from the exponents. And then from here, we're back in like math from a long time ago. Subtract your x. So I get those on the same side together. And then subtract the 3. And that's it. That's our answer. X equals -4 for the first one. Okay, question number 2. X is in the exponent. So can I match the bases? Yeah, I can actually. It's just that you have to rewrite both of them this time. So I can use a base of 3 for the first one, using parentheses, just kind of a visual cue that I need to distribute, and then using a base of 3 for the second one. So remember, we can only disregard the bases if we've already satisfied the fact that the bases match. So, I'm not going to do that yet. I'm going to distribute first. So keep the base, distribute, keep the base, and then distribute. Then we've satisfied that the bases match. Again, it's an equation, so the left and the right-hand side have to be equivalent to each other. 3's match. We can kind of check those off the list. Now we just need to satisfy that the exponents need to match. So I'm just looking specifically at the exponents. And then minus the 3. Looks like I get x equals -19. So not so bad. So on this slide, we're looking at exponential equations where you can match the bases. You might only have to match one of the bases or do work on one of the bases. So question number 1, or you might actually have to change both of them. It happens. Okay, question number 3 and 4. Same idea. They're just a tiny bit more complicated. It's like another wrinkle to this. So if we take a look at question number 3, the biggest issue that we have right now is that the bases aren't on the same level. So think about the level. Like this 4, if it was in a fraction, would be on the top of the fraction. Well, if you look at this fraction, there's a 1 on top. So if I compare the same level in a fraction, you can't hook up the 4 and the 8 because they're not on the same level. The 8's down, clearly. We need the 8 to come up. So I'm just going to use negative exponents to bring that guy up. So this is going to be 8 to the -1 power. Use parentheses to help myself out here. And I am going to show all of my steps. I'm just going to make sure I don't lose anybody here. And I'm going to go ahead and distribute to get rid of this set of parentheses. Okay, now that the 8 and the 4 are on the same level, so nobody's in the bottom of a fraction where somebody else is in the top of a fraction. Now, can I match the bases? Yes, of course. I can rewrite them with 2's. So I'm going to rewrite that as a 2 cubed. And now it's just like what we did on the previous questions. And then I'll rewrite that as a 2 squared. Distribute so I can get rid of the parentheses. And then negative 10x plus 28. And then once you get the bases to match, remember, these are equivalent statements. So you got the 2's, check them off. Now we need to get the exponents. So we've got 9x minus 30 is equal to negative 10x plus 28. I'm going to add my 10 to the other side. Add my 30. And then divide by 19. And so I get x is equal to 58 over 19. All right, let's take a look at question number 4. Where's the x? It's in the exponent. Okay. Notice that the 25 and the 5 are on the same level. So that's great. I don't have to do the negative exponent business I did just a second ago. I do need to get the bases to match, though, which in this case, I really only have to fix that, well, adjust the left-hand side. So let's rewrite our 25 as a 5 squared. And then just copy down the right-hand side. Don't have to mess with this one, so that's good. Distribute. So it's going to give me 24x minus 18. Carry down the negative 3x squared plus 9. And then continue. I got the 5's to match. Don't need them anymore. Let's take a look at just the equation of the exponents. Okay, so the reason why I waited to put this one in is because now I have an x squared. So I have an x squared and an x and an equal sign, which means I'm going to make this equal to 0. So I'm going to move my 3x squared. I always like my x squared to be positive. 24x, and then I'm going to minus my 9, so that's minus 27. Every single one of these is divisible by 3. So let's divide all of it, both sides, by 3. So that's going to give me x squared plus 8x. Minus 9 is equal to 0. That factors x plus 9, x minus 1. 0 product property. I get x equals negative 9, x equals 1. And there's my answers. So because I have an x squared, I think it kind of adds like a little tiny wrinkle of difficulty because it takes you back to like integrated 2 and quadratics and stuff. Okay, take a look at the next one. Okay, now really this is we're kind of at the point where we do things in pre-calculus that we haven't necessarily done in integrated 3. This is the main reason why I wanted to do this video for you. What I'm looking at with question number 5 and question number 6 is I really am looking at quadratics. I really, really am. But it's the idea of using 𝑢-substitution here to see if we can turn this into something that's a little bit more palatable. So what I'm going to do is I'm going to look at the term that has the smallest exponent. I guess that's one way to think about it. So if I take a look at question number 5, my smallest exponent would be e to the x, or the x power. So here's what I'm going to do. I'm just going to use a dummy variable, and I'm going to let u equal e to the x. Okay, so I'll do a little bit of work first. So let's do 3. I would really like that to look like an e to the x. So I can just put a u in there. Well, if you take a look at the exponent here, you have a 2 times an x. All I need to do is rip the x and the 2 apart from each other. So I'm just going to put the 2 on the outside. So I know that if I were on this level of work right now, I would distribute or multiply those 2. It gives me back what I started with. Okay, now I'm just going to copy down the rest of this thing. 7e to the x minus 10 equals 0. Now I'm going to replace all of my e to the x's with a u. And see if we can go from here. So now I've got 3u squared plus 7u minus 10 equals 0. Okay, now we're back in quadratics again. So that one little tiny wrinkle at the very beginning of it with coming up with some dummy variable to help us out. So we're going to go ahead and factor this. So if you need to draw the boxes and do the diamonds, so be it, go right ahead. I won't stop you. And we're going to go through and see if we can figure out what this turns into. Put in my 10 and my 1, which is what you should have gotten. And then, so when we go through and factor, this is what we should have ended up with. Go ahead and do zero product property. This is going to give me u is equal to negative 10/3 and u is equal to 1. All I did was do 3u plus 10 equals 0, which I can just go ahead and do. So I'll show you what I did. I don't want to lose you. So I've got 3u plus 10 equals 0 using zero product property and u minus 1. And then I solved this guy. And I solved that guy. Okay, but you're not done because the question didn't ask you to solve for u. The question asked you to solve for, well, the only variable that was there, which was which was x. So what I'm going to do is I'm going to resub back in. So every u is e to the x. Okay, now, stop and think about this for a second. E is like 2.7 approximately. If I take a look at this very first one, this basically says 2.7 to a power is negative 10/3. There's no way 2.7 to any power is going to give you a negative number. This does not work. This guy is gone. That's one of our excluded values. So just toss it. Don't label it as an answer. Just cross it out. This next one says that e to some power is 1. Of course, you can exponential equal to 1. That's totally fine. So if you know what the answer is without actually showing work, by all means, I don't have a problem with that at all. I'm going to go through and do ln on each side because I need to get the x to come down. So using my properties of logarithms, ln e is 1, x equals ln 1, don't stop there, ln 1 is 0. Which you may have actually seen. If we go back here to the yellow highlight, e to the x is equal to 1. Any exponential to the power of 0 is going to be 1, except 0 to 0, but that's a calculus thing. We're not going to do that this year. So you could have looked at this and inspected and gone, oh, it has to be 0. Well, yeah, it is 0. We found it. Okay, question number 6. Exact same idea. I am going to find what is the smallest exponent and what it's attached to. So 7 to the x. I am going to let u equal 7 to the x. I want all of these to be 7 to the x's. So I'm going to do the same thing I did. 7 to the x squared. Remember, if I were to multiply those two, I get back what I started with. And then minus 4, 7 to the x, minus 21 is equal to 0. Okay, so everywhere I see a 7 to the x, I'm going to replace it with u, and then just copy everything else down. Squared, minus 4, minus 21 equals 0, factor, u minus 7, u plus 3, 0 product property, u minus 7 equals 0, u plus 3 equals 0, u equals 7, u equals negative 3. Don't stop there. You're not solving for u. So replace the u's with 7 to the x. Remember, that's what our dummy variable was. Okay. Now, you might just be able to look at it and figure it out. So 7 to some power is equal to 7. Okay. So we know that 7 to the power of 1 is equal to 7. There we go. Now let's take a look at the other guy. I don't care. 7 to the x is equal to negative 3. Not a chance. That is not going to happen. Get rid of that guy completely. And that brings us to the end. I hope it helped.